Our project is on designing of the coupling beams. For the designing of the coupling beams, we have modeled a G+22 building, and in that G+22 building, there is an opening in the shear walls. And above that opening, whatever that is left of the shear walls, we have taken as coupling beams or spandrel. So for that, we have obtained the moments of that beam through the analysis of the G+22 in NETAPS. And that shows like this. The spandrel flexure design, top reinforcement, and spandrel flexure design, bottom reinforcement. In top reinforcement, there is left and right, and bottom reinforcement, there is left and right. So here it states that in left, there is a minus negative 300 kilonewton meter, and right top reinforcement 0. And accordingly, bottom one left is 0 and right is 212 kilonewton meter, which is a positive one. So for this moment, we will design the coupling beam. So this is the spreadsheet or Excel we have prepared for the design of the coupling beam. In this, we have prepared a dynamic results in which we can put any length and width of the beam or depth or grade of the steel or grade of the concrete, which shows the results accordingly. So we have gone through two IS codes. One is IS 456 and another one is IS 13920. We have gone through IS 456 because the depth of the beam. It has given few clauses for the deep beams. So as I shown in the Word document, the support moment at left top is 300 kilonewton meter, which is a negative. Left bottom is 0 kilonewton meter, which is 0. And for 0 kilonewton meter, we have taken the minimum reinforcement, that is 573 mm square. So for the left top, we have given two zones, which is written in the IS 456 for deep beams. Zone 1 is 0.2D depth from the top of the beam, and Zone 2 is 0.3 depth from the either side of the mid depth of the beam. So for these two zones, accordingly, we have designed the 612 diameter bars at the zone 1 and 612 diameter bars at the either depth of the mid depth of the beam. So left bottom reinforcement, we have provided 573 mm square, which is minimum reinforcement because the moment which we got is 0. And the right top reinforcement and the right bottom reinforcement. So right top reinforcement, the right top moment we got is 0 kilonewton meter. We have providing the minimum area of the steel in the zone 1 and zone 2. Like I have stated in the left top reinforcement that zone 2 is the either side of the mid depth of the beam. And right bottom reinforcement, we got positive moment that is 212 kilonewton meter. And for that, there is no zones required according to clause IS 456. And for that, we have got diameter of the bar 16 mm square, 16 mm, sorry, AST is 892 meters mm square. Area of the bar is 201 mm square. Number of bars is 5. So if you go to IS 13920, there is a clause written for the coupling beams that diagonal reinforcement is required. So for that diagonal reinforcement, the shear force at the left side we got is 435 kilonewtons. This is also we got from the analysis of the G+22 building that we have the results are that we have taken from the Word only. So in the diagonal reinforcement, we have provided 418 diameter bars. Minimum has to be 17 mm, but we have taken 18 diameter bars of 4. In special confining reinforcement, we have assumed 8 mm diameter stirrup. So the larger dimension is 900 mm and the L by 6 is 200. L is the 1200 mm and 450 mm. So the maximum of three should be taken. That is 900 mm. And spacing is the 12 times of the diameter of the bar that we have provided in the left side of the beam. That is 72 mm. And same for the right also. The shear force we have taken from the analysis, that is 419 kilonewton, and we have got the stress 0.84, which is less than 1.24. So we have to consider the diagonal reinforcement, and accordingly we have taken the 416 mm diameter of the bars, and also spacing 72 for 12 times of the diameter we have provided in the right side, and also the maximum of the lengths we have obtained, that is 900, 200 and 450. So now we have to go through the stirrups. So stirrups we have gone by the clauses written in the IS 456, and IS 456 833.33 is the maximum of, if you see here, it is a maximum of the steel provided at the support regions 600, 612, 612 and 833. So we have to take 833, and from that we have we have got the percentage of the steel, and through percentage of the steel we have got the stress, and through that stress we have got the area of the stirrups and the spacing of the stirrups. So for that spacing of the stirrup, the clause states that the spacing of the stirrup should be the minimum of the one we got from the area, that is like 833, and also 300 and also 675 that is 0.75 of the 0.75 of the effective depth of the beam. So we have got 100.239 as a minimum, and we have taken spacing of the stirrup as 100.239 So these are the values that we obtained from the manual and ETABS. So if we gone through by all these values, we can say that they are only differed by maximum 5%, and at times even less than 5%. So this is the comparison of the reinforcement details in flexure design and also diagonal reinforcement. So how this looks in the practical is, like if we see this slide, this is a diagonal reinforcement, this is a longitudinal bars, and there are also vertical bars. So 0.2D is the first one zone, then 0.6D is the either side of the mid depth. That is 0.3 on that side and 0.3 on the bottom side. So total 0.6D. So 1200 mm and 900 mm is the dimensions. A is the left section of the beam and B is the right section of the beam. So in second slide, I am showing the section A of the beam, that is left, and section B of the beam, that is right. So as stated in the spreadsheet, there are two zones we have considered. So for each zone, there is a different reinforcement. So here it is 0.6D, 612 mm diameter, 0.6D means that 0.3D on the either sides of the mid depth of the beam, that is 612 mm diameters, and this is the bottom reinforcement. We got 416 mm diameter bars. The same accordingly on the right section of the beam. So this spreadsheet that we have designed or for the coupling beams, it can be used for any dimensions of the beam, for any depths and dimensions for the coupling beam, as in the coupling beams, for any grade of the steel or any grade of the concrete. So accordingly, the value will change and also the reinforcement details will change. Thank you.